Now we will try to discuss the different modes of the metal transfer generally observed in the gas metal arc welding process. So, first we will start with the modes of metal transfer, that is what one of that is the short circuit transfer. So, basically during the welding process, when the electrode come in contact with the workpiece material and it is just about to contact or gap is very less. So, at that time normally the low current flow through the electrode, and then droplet at the tip of the electrode actually grows slowly because of the low welding current. And then when the drop exactly touches the oil pool, then that short circuit creates basically, and that short circuit and current flow through this circuit actually changes. Now, due to the narrow arc gap, so molten drop does not attain at a very big size, and therefore, there may not fall, the transfer of the metal droplet may not be due to the gravitational force. That with this, once the short circuit establishes, then there is a abrupt change in the current flow. So, there is a continuous increment of the current flow, and then when there is a current flow, that amount of the heat generation also abruptly increases, and that actually results in the decrease of the surface tension force at that point. So, that molten metal droplet becomes more thinner and thinner due to the low surface tension at the high current flow. And from the figure also we can see that this is the figure shows the typical basically current versus time graph during the short circuit metal transfer. So, initially when there is a short circuit established, then we can see there is a continuous increment of the current reach the peak value. So, the maximum current value. So, at that point, and it actually reduces the size of the droplets, and then at this point there is again there is a decrement of the current, and it reaches certain values. For example, it reaches these values, and the arc actually creates in between this period of the time, such that molten metals becomes more and more thinner due to the high generation of the heat during this time period. And after that, the molten metal is transferred to the oil pool, and then once transfer the oil pool, the thinner metal transfer the oil pool, and then one arc gap is establishes between the electrode and the workpiece. So, but when arc gap is establishes, at that time also there is a abruptly increment of the arc voltage. So, short circuit metal transfer can be characterized in such way that there is basic three components. One is that creation of the arc, and then short circuiting, and that pinching. Pinching means basically due to the pinch effect, it is detach the molten droplets from the electrode. So, that this typical cycle actually repeated over and over. So, in this mode of the metal transfer, that is called short circuit mode of the metal, this mode of the metal transfer we can find out in the different gas metal arc welding process. We observe this type of metal transfer. So, this is the one type of metal transfer. Now, we can see the globular transfer, that in this form, probably that here also the condition of this type of droplet formation, that welding current is typically low, but it is not less than that of the short circuit transfer. And when arc gap is here, in this case also arc gap is more, in the sense that it is as compared to the short circuit metal transfer, the arc gap is typically more between the electrode and the workpiece, so that droplet can grow within that period of the time. So, then once the droplet grow, but in this case since we are using the low welding current. So, basically the droplet can grow very slowly, but it can continue to grow until and unless the gravitational force exceeds the surface tension force. So, once the gravitational force exceeds the surface tension force, then the droplet actually detach from the electrode tip and it comes to the molten oil pool. But what is the mechanism of the detachment of this droplet from the electrode tip? So, not only the surface tension force is responsible, because there is also effect of the other drop holding forces. So, it will try to make the balance between the surface tension force and other drop holding forces, for example, in electromagnetic forces, and that actually play a role here. But the droplet transfer is mainly happens here due to the gravitational force of the droplet. So, once it grows into the sufficient size, the droplet detach from the electrode tip and it takes the position within the oil pool. So, typically the size of the droplet or exactly the transfer of the droplet occurs when it attains the size is larger than that electrode diameter. For definitely in this case the globular transfer of the molten metal, there is no short circuit takes place in this case. So, apart from short circuit metal transfers, globular transfer, there is another type of metal transfer we generally observe in the consumable welding process using the consumable electrode, and that is the spray transfer. In the spray transfer, what happens? In this case, typically the different from the other two cases, that it is a high welding current density as compared to the globular metal transfer. So, in this case what happens? The high welding current density and basically results in the high rate of the melting, and also at the same time the greater amount of the pinch force actually act this type of metal transfer. So, droplets are actually formed very rapidly, and so transfer of the droplets, the frequency of transfer of the droplets is normally more in this type of metal transfer, but it is mainly characterized with the high current density. So, once droplets are formed very rapidly and they at the same time it also pinch off also very quickly, and then it becomes the part of the final oil pool. So, obviously, the size of the droplet is definitely less than that of the globular droplet in this case. So, high welding current increases the temperatures, and then when there is increment of the temperature, that actually lowers down the surface tension force, and of course, the high current density are the other way, it also favors the increment of the pinch force. So, the combining the decreasing surface force and increasing pinch force, both together favors the formation of the resistance to the droplet detachment, and that finally, if you look into the figure, the actually droplet forms, it says very small droplet forms from the electrode and continuously transfer to the main welding component. So, in this case, this type of droplet transfer is specifically important when there is some intricate part is needs to be welded. So, in that component, that type of component welding, the droplet the spray transfer is the more preferable situation or more preferable condition in that case. So, definitely we can see that short circuit transfer, the globular transfer and the spray transfer. So, all these cases here we can control that transfer of the molten droplet, although it is a very complex phenomena, because there is so many interactive forces is acting, and normally these three forces, gravitational force and the surface tension force and the electromagnetic force, that actually play the significant role, the detachment of the molten droplet from the electrode tip in case of the welding of using some consumable electrode. So, in that point of view, it is although it is a very complicated phenomena, but still by normally changing the current density or other secondary parameter, for example, shielding gas environment and gas flow rate, that also actually influence the droplet transfer. So, if you want to discuss all on details about this typical droplet transfer in the gas metal arc welding processes, we need to consider all these parameters, but to some extent it is possible to control the type of the metal transfer depending upon the need of the welding situation or welding of different specific cases. So, apart from all these three types of droplet transfer, there is another droplet metal transfer also, we modes of metal transfer we generally observe in the welding process, that is called the deep transfer. So, deep transfer is almost similar to that short circuit metal transfer. Here also the welding current is very low and feed rate is very high. So, here also the electrode is short circuited with the weld pool, and that leads to the melting of the electrode and transfer of the molten drop. But deep transfer, deep transfer actually differs from the short circuiting transfer in terms of the arc gap. So, here the low welding current and the narrow arc gap and even at normal feed rate is the results in the short circuit mode of the metal transfer, but deep transfer differs that primarily by the caused by the abnormally high feed rate. So, deep transfer also also similar to the short circuit mode of metal transfer, but deep transfer is generally observed when the feed rate is the moving of the electrode is basically it is a very high, but as compared to the short circuit transfer, because short circuit transfer metal transfer generally observed at normal feed rate, but in this case the feed rate is very high. So, in that way the different modes of the metal transfer, just I have tried to give some basic idea of the different types of the mode of the metal transfer, and then there may be the scope of these modes of metal transfer including considering the effect of the other parameters, for example, the influence of the shielding gas and the angle of the torch, that also play important role, and gas flow, shielding gas flow rate and the arc length or arc gap all actually play the role in the metal transfer. So, in this way now I will conclude, that means for the part of this module or this chapter in this way, that first we have discussed in the different brazing and the soldering process and basic mechanism of this process and their applicability in general of this process. But the significant point related to the brazing and soldering process is that normally we can use this process for joining of the dissimilar materials. So, in this case, but main obstacles of this using the brazing and soldering process for dissimilar combination of the metals is the mechanical strength of the weld joint. It is not, we cannot expect very high mechanical strength for brazing and soldering process, and when we try to compare the other fusion welding processes. So, this is one significant point. Next, that we have discussed also the adhesive bonding process, and there are several methods of the adhesive bonding process and basic principle mechanism of the adhesive bonding process. But practical point of view, what we understand from this adhesive bonding processes, that curing of one of the component of this process, that actually takes considerable time. So, the process is very slow. So, in that sense the adhesive bonding maybe most of the cases the adhesive bonding is normally used for the aesthetic purpose. This is, but commercially this cannot be a very alternative to other fusion welding processes, where the mechanical strength of the joint is the main significant. Third point is that when you try to make the automation of the any kind of arc welding process, then it is always desirable to use the field start in the to initiate or to start the arc as compared to the manual arc welding process. So, that is also one important aspects in case of arc welding process. And third point is that in arc welding process we use the different types of the current, either AC current, DC current, and even for DC current we have used the different polarity. So, that means direct current electrode negative or direct current electrode positive, both polarity can be used depending upon the applicability of the process, or whether we are using the consumable electrode or whether we are using the non consumable electrode, because the type of polarity actually decides the amount of the heat generated in the workpiece or electrode, in which cases it is more or which cases it is less. Normally DC EN polarity, the amount of the heat is generated in the workpiece is more, and in this case the less amount of the heat generated in the electrode metal. So, that is also desirable. So, in that sense DC EN polarity is generally used for the non consumable electrode, but in other way also in case of consumable electrode, when you are using, it is preferable to use the DC AP polarity, but of course there is other factors also to decide the polarity, but in general that melting more amount of the heat generation is the our criteria to select the different type of welding process. So, DC AP polarity is more preferable for the when we try to melt the consumable electrode. And AC current, of course, always we use normally when there is a need of the cleaning action in one of the cycle. So, that that one case is that it can AC current can be impact on like that cleaning of the surface of the weld metal, at the same time generation of the heat and creating the weld pool, or maybe finally make the weld joint. In general, we have, if you try to compare the efficiency, thermal efficiency in case of consumable electrode or non consumable electrode, probably the using the consumable electrode, the efficiency in general it is more as compared to the non consumable electrode, because in case of the consumable electrode, the generated heat try to consume the amount of the molten metal, and the molten metal finally becomes part of the weld system. So, in that sense the thermal efficiency is more in case of the consumable electrode. Finally, if we analyze overall the droplet transfer, in general we can say that in case of low current and high current density, in case of low current preferably we can use either short circuit type of metal transfer or globular type of the metal transfer, where the metal transfer occurs only due to the gravitational force of the molten droplet. With other way, if we consider the high current density or high welding current, we can expect that the metal transfer actually occurs in the spray mode, and the spray mode is maybe well controlled, or it is more preferable when we try to this type of metal, when you try to keep the some intricate part of the component we want to join, or there is a requirement of the metal transfer in that part. So, in that case spray mode is the more preferable mode of the metal transfer in case of the welding process using some consumable electrode. So, with this I conclude the one part of the module 1. Now we will try to discuss in the next part of the of this module 1.